Hi everyone, this video is about the introduction of network in the graph theory. This is the latest syllabus of KSSM in Form 4 Mathematics. Before we go into details to discuss about the graph theories, let's try to solve the problem of Königsberg's bridge together. The legendary bridge of Königsberg problem had frustrated many people before the mathematicians Leonhard Euler solved the problem. As we can see from the map here, this is the old city of Königsberg in the Soviet Union, which is in Russia now. In 1736, they had planned a celebration featuring a grand parade. Designing the parade route was complicated by the fact that sections of the city were located on the islands in the preserved rivers and connected to the mainland by a network of 7 bridges. City fathers insisted that each bridge should be crossed by the parade once and only once. Well, if you were Euler, can you take a walk through the town and visit each part of the town of Königsberg by crossing each bridge only once? To make it more easier to visualize the map, let's simplify it together. As we can see here, there are 4 major parts of land, which is land A, B, C, and D. There are 7 bridges and we label them as P, Q, R, S, T, U, and V that connected the lands together. To draw it in the mathematical way, we can draw it like this. Well, you can now take out a piece of paper to draw the diagram. Try to draw each of the lines only once without lifting your pencil from the paper. You may pause the video to try it now. So how? Did you succeed to solve this problem? I'm sure most of you can get the answer right. Never mind, let's take a step back to understand the network in the graph theory. Before we solve the problem, let's learn some basic concept of network. So, what is network? A network consists of points and lines, where the line connects all the points to form a network. As we can see from the diagram on the left, there are point A, B, C, D, and E. A point is also called as a vertex or a node, where there are lines to connect or link all these points together. The line can also known as the edge. So, we can call the whole diagram as a network or a graph. Yes, that's right, it is a graph. But it is not this kind of graph. They are both called graph, but they are actually different. The graph that we are going to focus is this. Other than that, the number of edges that leads to the vertex is called the degree. For example, there are vertex A and vertex B here. Vertex A has degree of 3, as there are 3 edges leads to the vertex. So, we can call it as an odd degree, because 3 is an odd number. While for vertex B, it has degree of 2, as there are 2 edges leads to the vertex B. And of course, we can call the vertex B as an even degree, because 2 is an even number. For example, the vertices A, B, and C in this network are even degree, as each of the vertex has degree of 2. However, for the vertex D, there are 3 lines leads to the vertex. Hence, it has degree of 3, and it is an odd degree. While for vertex E, it has only 1 edge leads to the vertex. Hence, it has degree of 1, and it is an odd degree as well. So, we can conclude that there are actually 3 even degrees and 2 odd degree in this network. Besides that, a road around a graph that visits every vertex once is called a simple path. Well, as we can see here, if the path is like that, from A to B, and from B to C, then from C to D, next from D to A, and this is called as a simple path. However, a road around a graph that visits every edge once is called an Euler path. Well, let's label the point first. If it is an Euler path, then the path should be from E to F, then from F to G, next from G to H, then from H to E, last but not least, from E to G. Yes, this is called as an Euler path because the roads visit every edge only once. An Euler path can also be called as a traversable network. It means that if you can trace a shape without lifting your pencil and without going over a side more than once, then we can say that the network is traversable, or it is an Euler path. There are several important criteria for the shape to be traversable. First of all, none of the vertices are of odd degree, or there are exactly 2 vertices are of odd order and the rest are even. It means that a network can be said as a traversable if there are only 0 or exactly 2 vertices are odd degree. Let's look at the example below. Can you predict or determine which of the network is traversable? Well, let's analyze the questions together. For the first network, vertices A, B, D, and E have degree of 3, while vertex C has degree of 4. So, we can conclude that it has 4 odd degree and 1 even degree. Since the traversable network either has 0 or exactly 2 odd degree, but the first network here got 4 odd degree, hence it is not a traversable network. However, for the second network, vertices I and H have degree of 3, while vertices F and G has degree of 4. So we can conclude that the graph or the network has 2 odd degree and 2 even degree. Since there are 2 odd degree in the network, hence it is traversable network. So, let's back to the question just now. Can you now draw the lines passing all the edge once without lifting your pencil from the paper? Okay, let's analyze the network of roads of the Grand Parade in the Königsberg city. As we can see from the network shown, vertices A, C, and D have degree of 3, while vertex B has degree of 5. Hence, we can conclude that there are 4 odd degrees in the network, or we can say that there are all odd degrees. So, it is actually not an Euler path. Indeed, we cannot draw the lines passing all the edges once without lifting your pencil from the paper. So, actually there is no solution in these conditions. However, during the World War II, all 7 bridges were destroyed by an Allied bombing raid in 1944. And there are only 5 bridges were rebuilt. Now, it is possible to visit the 5 rebuilt bridges via an Euler path. Okay, let's prove it together. Since there are only 5 bridges are rebuilt, so we can draw the graph or the network like that. As we can see from the network, vertices A and D have degree of 2, and they are even degree, while for vertices B and C, they have degree of 3, and they are odd degree. So altogether, we have 2 odd degrees and 2 even degrees. Since there are only 2 odd degrees, that is in B and in C, so we can actually draw the edges once without lifting the pencil from the paper. Let's try to draw it and see. Okay. Since there are 2 odd degrees, that is in vertex B and vertex C, so we can either choose B or C to become our starting point. Okay, I would like to choose C as my starting point. Okay, first and foremost, I can draw from C to B, and then from B to A, next from A to C, then from C to D, last but not least, from D I can continue to draw to B. That's right. So we can say that it is actually an Euler path. Or we can say that the network is traversable. As a conclusion for this video, we can say that graph can actually be used to model many types of relations and processes. Indeed, many practical problems in real life can be represented by the graph. By emphasizing the applications to the real-world system, the term network is sometimes defined to mean a graph in which attributes are associated with the vertices and edges. In fact, the applications of the graph theory is widely used in different areas of studies. For example, the area of transportation, computer science, biology, chemistry, and guess what? It is also very useful in the area of social networking. Well, this is all about the introductions of network in the graph theory. Thank you for watching. Bye.